Okay, on this one, you can start with a line. And there's a couple different ways to show it, and I'm going to intentionally show it one way and then say that there's a better way. But if I wanted to find a perpendicular bisector of the line AB through the segment AB, because you know the line goes forever both ways, but if I'm just thinking about the segment AB, I find a circle with center A and radius larger than the middle of the line. So see, here's about the middle, right? It's got to go over the middle. And I don't have to put it on the line itself. I can put it right there. So there's a circle, and if you want to scoot back, you can see that. And then get a compass out. And you want to go from A to that distance, whatever that is. So I'm going to hit A, and then it kind of made an intersection without showing it. And then I drag it over to B. So if you want to show your intersection, see how wide this is more difficult? Because I don't have a point there to grab.
So what I did with the compass, and then I touch A, and I touch where they intersect right here, and it just highlighted it.
Right, now touch B. So it highlighted it because it said, oh, I'm making a circle that big. So there's a compass, imaginary compass that's held open, it's holding open. So then center it at B. Now what's the key part here is that this arc right here that makes this construction arc right here, or construction mark right there, construction mark there, and this arc, they've got to be more than halfway, and I'll show you why in a second. But these are just like construction marks. Some down here. What we've just created is the perpendicular bisector again. And I'm going to make a line that goes through those intersections. I'm going to turn those circles off. And then I'm going to enlarge D. You can choose D by clicking on it over here. Oops. And you can right click on it. I'm going to say style, I'm going to make it bigger. Well, same style that way, but just size is bigger. So keep an eye on this point as I move A and B. And if I go too big, oh, I'm sorry, my circle. If my circle gets too small, it disappears. Why does it disappear?
Because I don't know if it intersects.
So what we have here is, if you construct a perpendicular bisector of a segment by constructing any 2 points equidistant to the endpoints of the segment. So there's the endpoints of the segment AB, and these are equidistant. In other words, think of them as like the third vertex on an isosceles triangle. How about, rather than just thinking that, let me show that. So I'm going to show my circles again. I'm going to show you what happens if I go too far, shorter than halfway. It disappears. There's no intersection to form the line anymore, right? Because this circle right here is some original circle that I made that was more than halfway across. And this circle right here is a compass derivative of this one. So this one's derived off of this one. So if this one gets smaller, so does that one. They don't have an intersection. And then you get to the point where they do have an intersection, then you can go bigger, 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 bigger. Okay? So what we'll find out is that it's easiest just to make this original circle go all the way up to radius b. That's the easiest way to do it. Because then you know that endpoint B always exists. So anywhere you move A and B, you'll still have a circle. Okay, now I'm going to show the triangle legs that I just referred to. A, D, B, D. So anything that's on this perpendicular bisector is essentially the third vertex in a triangle that's isosceles. It has base angles congruent. And you can see that every time you move it, doesn't matter if I make it a skinny triangle or wide, or if I change the original circle that the construction came from, unless I get to a certain point and then they vanish. So you don't really need these line segments here, which means I want to kind of change their style. And then you can think of them as just being like something measuring the distance. That D is equidistant from A and B all up and down line G. The label for line G is down here. I know you can't see it on the screen. So that D right here, or any point D1, D2, D3, D4, any point along this perpendicular is going to be equal distance, have the equal distance from DA, D to A, as it does from D to B. Can you construct it?